just a little bit about my background. Um, um, so I have ran a laboratory for water testing in the state of Minnesota. Owned a laboratory, had a bottled water company. Um, at one time, we sold. Um, I've got some lettered degrees in the water industry, etc. So all to say, I've spent a lot of time thinking and learning about water. We're vertically integrated, our company, so we have mechanical engineers, we have a chemist, we have fabrication and assembly, and then installation and service. Um, so that's a little bit about us. And what we're going to talk about today is your water system ready for the future? And you know, the way I look at the fabrication industry over the past 20 or so years, water was an afterthought 20 years ago. And, most people just used pits and discharged water. Typically, a lot of times it was outside to storm water. Uh, and and that's being enforced so heavily in most major markets now that very few people are doing that. If and when they do it, it's usually kind of under the table, just because there's so many regulations requiring that, not to occur. Um, but during that 20 years, people, when they ask about water systems, or they put a water system in, it was typically done, just as a band-aid. Let's just do as little as we can to get by. And over the years, when people experience the pain and suffering around dealing with a water system that was not meeting the needs and challenges of the facility, people realized, oh, we need to invest more. We want nicer equipment, etc. So the manufacturers in the industry that make water systems have matured as well, and the equipment has gotten more sophisticated. Um, but things we'll talk about today is a little bit about the regulatory enforcement, operating costs of water systems, how the quartz recipes have changed. You all are probably aware of how those recipes have changed, and now there's recipes that have less silica in them, and they're trying to work on those, moving towards more of those types of recipes. Um, the, our competition continues to get stronger and stronger throughout the industry, not just in countertop fabrication, but in the equipment, the CNC equipment, the water treatment equipment, the tooling, etc. Our employees are more educated, so they're being more demanding as well, and about the safety of their workplace, etc. Um, we think water is one of the most overlooked production tools. In the past, I don't think people would have thought of it as a production tool, but fabricators have struggled with managing water and saw the downsides of not having that water available when needed at the quality needed, and the cost of that. People now are considering it as a production tool. And I think we're all familiar that the reason we use water in the industry is to control the dust and to protect tooling. And I think we're all aware that as our water quality suffers that we're using, we notice it in our product. We also notice it on the tools, the capital equipment itself. And then some of you may or may not be aware that water quality, that recycled water, directly affects the silica levels in the shop. If the water is very dirty, it's going to carry silica back into the shop, and when it dries, you're going to have elevated silica levels. So jumping right into the 7 signs your water system might be holding you back. If you notice your water looking very cloudy or turbid at times, definitely something to look at how you can improve that. And there are add-ons now and chemistries available that can improve your water quality, even with an existing water system. Again, anytime you see cloudy or milky or gritty water, you're going to have a high silica load in most fabrication facilities. Anytime that water gets reused, it's going back, getting on surfaces, getting on your equipment, getting on the floors. And anytime that dries, people walk through it. I think you're all familiar with that. There's been some testing by a few fabrication outfits where the silica levels were actually highest in the carpet area coming in from the shop into the office, and the spaces around that entry point was actually higher silica levels in the air than it was outside in the shop. So it's something to be aware of, and that's because your shoes are grabbing that wet slurry and moving it into that carpet area, and then when it dries out, it can become airborne.
It's a form of it's a form of contamination that people don't pay attention to. I mean, when I was in the fire service, contamination was everything. And this is just another one of those things that most people don't even think about.
Right, right. So if you see footprints going into that carpet, that's a sure sign that, and how can you, there are some ways to mitigate that with any water system, and we know guys who are using fresh water to wash down, floor scrubbers to scrub, 2 or 3 times during the day, especially in that area moving back into the office, but uh, any traffic areas to try to keep that dust down. If the water's impacting your production, where your hand polishers or your CNC nozzles, are plugging, or your seals on your pumps are failing and causing an emergency where your shop's down because a pump is not running and you're waiting for that part or you're overnighting it, there can be, escalating costs that just snowball with failures. Um, Tooling, if it's wearing faster than normal, or if you're seeing a lot of corrosion, um, these are all things that, are pointing to, hey, giving your water system a little attention and looking at what can be done to improve some of these touch points. Um, yeah, your polishing pads, etc. If you're noticing life changing, if you're seeing equipment or tooling costs or maintenance costs, especially on pumps, that's usually a water system problem. A lot of times it may not be the pump itself, but it's the water the pump is pumping. If your slurry management feels out of control, your water management. So if you're throwing people at the problem and you're having problems because someone who had the knowledge left the company and everyone's really struggling, that's a sign that that water system is holding you back. Now, a lot of times you can reach out to your existing equipment provider and get some training, whether it's a Zoom or Teams meeting or an on-site consultation to come in and help get you back on track. Um, if you see your trenches filling with mud really quickly, or your pits, uh, again, frequent pump failures. That's probably the most common one we see with customers. That's the most common sign that there's water issues in the shop. Pit cleanouts, we talked about that. And then the floors, if they're visually dirty, gritty, dust on slabs and equipment, that's a sign that that recycled water is passing silica back into the shop due to how dirty it is and cloudy. If your production actually slows down when your demands go up, we seem to see this, and sometimes it's plumbing related, where the plumbing manifold in the shop is not sized properly, and anytime the flows rise in the shop, the pressure drops, and then we get pressure alarms, and CNCs will shut off, or the hand polishers at the end of the shop won't have enough water flow to adequately do their job. Or if your clean water filtration method and you're using a clean water loop and you don't have enough clean water, and so when your production demands go up, you're actually noticing that you're not getting as much throughput. That's a sign your water system is holding you back. Again, shop growth. If you're trying to use more water, then the system will put out, and that's common as shops grow and evolve, that they run out of capacity in their existing water system. Flows, if your flows and pressure drops during peak times, people complain about that, and that's another sign. And so it sounds funny to say production slows down when demand spikes, but it's not uncommon to see that. Employees are managing what equipment operates and when, and this is one we hear all the time. Well, we don't use that line polisher unless this, these CNCs are we're removing material, doing some material handling, or we tell them to turn the CNC off for an hour or two. And that's a sign, hey, you should be looking at pump capacities or plumbing or your water system. If your operators are reporting dirty finishes and more rework, that's a sign that you may have an issue here with your water system. And hazy polishes, a lot of times I would say that's most common training, with your polish guys. But hand polishers that are clogged or the pads are not working effectively, that's something that's not uncommon, where they'll start, the flow to that polisher will slow down, and the pads will not be as effective due to poor water quality coming into the hand polisher. As you guys are all aware, the silica compliance concerns are growing rapidly. We all know what's going on in California. That what happens is these local agencies and OSHA groups that are working on silica compliance all throughout the United States learn from each other now. And so when one state targets an industry, it spreads very quickly throughout the US, compared to 20 years ago, when you might have small pockets of local agencies that were concerned, but most of the rest of the country was not focused on it. And that, like we said in the beginning, water, all your water, recycled water, if it's not clean, it's going to have fine silica in it. And as that water gets used in the shop, it ends up depositing silica on all surfaces. And the one that's the most prominent for respirable silica is the floor. That's where we're going to really see it. We did a test in a shop recently where we had 3 silica testing devices, and the in that particular shop, the forklift activity was the good news is the shop was below 50. I think they were around 20 for a high level. They were below the 50 threshold, but their highest levels were where the forklift was moving through an area all day long. If your employees are complaining about the air quality and their clothes getting really dirty, that's a good sign that your silica levels are out of control, and very likely your recycled water's dirty. If you're just noticing more and more maintenance and pipes, nozzles, pits, tanks, broken components, pumps burning out, water production not keeping up, if you're delaying production work to try to fix problems on the water system, whether it's replacing filters, um, filters clogging, quickly, sometimes multiple times a day in some shops, uh, that's a sign that the main water system is not doing its job. And, sometimes that's as simple as dialing something in. Something needs adjustment, and it can make a big difference. One thing we see is that the modern systems now reduce labor where the old systems created more labor and require more labor. What we want to see in a water system, we want to see visually clean, relatively clear recycled water. In a perfect world, it looks like drinking water. That doesn't always happen, but if we can keep that visually clear, so you can take a water sample and read something through the water sample in a water bottle, a clear water bottle, that would be an ideal situation. If you have water like that, you're going to eliminate a lot of these problems. If you have consistent pressure and flow in your shop, if there's a way for that sludge to not require a human intervention when it's removed from the system, whether it's a filter, like a filter press or a filter cartridge or a sludge bag, if that process is automated, that's an typically an ideal situation. More and more employees having dedicated, wise employees is not the norm many times, and most of the older water systems required a dedicated, wise employee. So most of the new modern equipment is moving away from needing a really educated key operator um, to perform. If there's any new water system, the goal is to reduce the need for pit or trench cleaning. We we have three different models now of pit mixers that keep the pit solids from building up in the pit, keep it suspended and homogenized so it's easier to treat. And I think we're going to see that more and more in the next few years in the industry as people will have a mixture of some sort to keep the pit from settling. Um, and then compatibility with slurry additives, whether it's liquid or dry additives that clean the water or cool tooling in the future. Um, Water systems, as chemistries are developed, you want your water system to be compatible with those new developments that may happen in the next 5 to 10 years. It, you're going to have lower tooling costs. You're going to have lower maintenance costs with cleaner water. And something that's important to look at is a scalable design. So as your shop grows, that water system has a capability to grow, and it's not set in a small niche of volume that it can handle. And I'm sure you all you're aware that equipment's coming out now. There's equipment in the industry that has data logging, remote monitoring, detailed warning messages. That's all something that you want to look for in new equipment. The capability to send warning messages to your email or text, to keep track of how many running hours or how much production went through a piece of equipment, how many linear inches of a certain profile is produced, etc. That's all really important data for managing your shop in the future, especially with AI tools that are coming out that will replace a lot of our numbers crunching and brain needed to get that actionable information that helps us make good business decisions. Just a practical checklist here. Things you think about, does your water flow drop when multiple machines are running? In a normal shop, if you add up all your water, each piece of equipment, all the water usage, you might come up, a decent sized shop might be 120 gallons per minute peak flow. It's very common that that shop will only run around 35 gallons per minute when we add load and unload times and, machines are on and off. It's usually a third of somewhere around a third of that max flow rate is where we're operating on a consistent basis. But there'll be times during the day where that flow gets really close to peak flow. And when that happens, do you experience pressure drops and sometimes error codes? That's an important thing to be aware of. If you do, how often is it happening, and how do you eliminate that? We've seen people put in pressure tanks or just larger pumps or replace entire water systems, depending on answers to other questions. Uh, and, and probably a big one we see is, are there times when your employees are choosing not to run equipment due to a lack of clean water or lack of flow or pressure? That's if that's happening. Um, we see that on smaller systems when people outgrow them, where they can only produce so much water, and the shop is actually juggling around that bottleneck. Some quality questions: is your water visibly cloudy or dirty? Do your floors look hazy, cloudy, dusty? Tools lasting as long as they should? These questions will help with water quality issues, just identifying it and paying attention to it, and then looking for the solution. A lot of times, the existing water system is capable. It's just not running the way it should be. It's not being used properly, or something is adjusting. So it's important to reach out to your manufacturer if you're running into those types of problems. And yeah, and the one that we're all aware of is, the silica issue. Are there air quality and dust issues in the shop? And how can you mitigate that? Through ventilation, through cleaning, through improving your water quality on your water system. Those three seem to be real big ones. If you can make sure your recycled water is as clean as possible, and you can keep your floors clean and your surfaces clean, and then keep your ventilation in check, uh, you should be able to minimize those issues with silica. The big maintenance ones are pump seals, filters failing frequently. A lot of times that'll cause a hard down situation in the shop, where there's no water flow, and you're either going over city water and then trying to deal with your excess water, or your shop is just down and you're sending people home. Uh, and then if cleaning feels like a constant activity, uh, where you're putting a part-time or full-time equivalent employee on it. Uh, just Here was a customer we have had almost 20 years now. They're an architectural stone. Uh, they do some surface, but it's mostly architectural stone exteriors. Uh, that just looking at pure water quality, similar technologies, but new equipment, new controls, new chemistry. Uh, we dropped their silica levels by almost, they're about a third of where they were prior. Their hours per week of maintenance was 4 to 5 hours. Now it's about 15 minutes. Their pits, trenches are much cleaner. Uh, this is very common feedback from people that are moving into newer water systems, and some of you may know there's some really exciting dry chemistries. They're a little more expensive to operate, but they're doing wonders with silica levels and cleaning the water. Uh, so I'd like to open it up to questions and or thoughts from some of the people on the call.
Absolutely. Does anyone have questions?
So we have an EBCO system in our shop,
Sure.
and people walk into our shop and they tell us how clean our shop is, and I'm going, what is clean exactly? What do we compare? What is clean? And that's a definition that I think that needs to be identified. What is clean and what is not clean?
Yeah, great
Because
point.
depending on who you ask, you're going to get a different answer.
Right.
But I
That's
think that if your water stinks to high heaven, like sewage water, there is something wrong in there. And you've got it's the algae buildup and all of that sorts of stuff. It's going to make people sick. And the way that we deal with that is we start adding chemicals to it to kill the algae. But what is it doing to our workers?
sure, sure. That makes quick. That's a good question. Something that's not being used much in the industry yet. First, what is being used a lot is bromine. Um, it's widely used. Chlorine is used, but not recommended by most manufacturers because it's very aggressive on steel. And, it will oxidize things, so you're going to get more corrosion, especially if you're super hyperchlorinating, where you wait for the odor to come and then you chlorinate heavily once a month, let's say. That that's can be really really hard on the steel in the shop. Bromine's a little softer, but it's still an oxidizing agent. Both are really not used to kill; they're used to control growth primarily. So there's chemicals used that are called biocides, and I don't think any of the water treatment equipment manufacturers currently sell those in the industry. And one of the reasons is they're a pain in the butt to transport, and they have to be registered where they're used. So, uh, for instance, if you're in Ohio, you need to buy a biocide that's registered in the state of Ohio. Um, Most shops get by on $300 or $400 a year a biocide, and there's not a lot of people using it, but it's very, very effective at killing bacteria and algae. It's used in a normal shop that has 6,000 gallons of water in their entire closed water loop, let's say. Um, you're going to use about 16 ounces of that product a week, just and a lot of guys that do use it just hand dose it. And it is not safe for the employees to drink that. Straight it's a biocide. It would be like drinking chlorine. You can't do that. But 16 ounces in a shop that has a few thousand gallons of uh, water in their system, it's not going to hurt anyone. The benefit of the biocide is most biocides are non-oxidizing. They're not hard on steel, but the benefit but they do a kill of bacteria. Um, One of the issues in a fabrication shop is you even if you super chlorinate, uh, you a lot of that bacteria will be on the walls or under mud in the trench or in your sawjet bed, and you can't adequately get to it where it'll those barriers of mud will prevent the bacteria from being killed. So it's hard to get rid of if your shop has got a lot of solids in trenches, pits. So if you do have a bad odor, the best thing to do is just clean, do a real deep cleaning where you get your trenches completely clean, replace the water. If you start out with like a bromine, like a pool chlorinator type ball with bromine pucks in it, uh, the way you got to be careful about overdoing it because the bromine will attack steel in quantity if there's too much bromine in your shop. And there's a device called an ORP tester, so uh, oxidative reductive potential. Some of that is automated on some equipment. Some of it is you can buy handheld, um, but that will tell you, oh, our level's good. And usually a level around 100 to 250 isn't good. Once it approaches 500, it's getting too high, and you're going to have some corrosion concerns and potential with the equipment in the shop. But between doing a biocide once a week and using a very low level of bromine, that's where I believe the industry will fall in the future, uh, because it's the most effective method. If we were in a cooling, a big power plant where they have lots of resources and engineers, they're all using biocides, and they're all using that to control bacteria, and most of them are using a very low level of an oxidating agent like bromine. So a biocide once a week with a very small amount of bromine is a really common in large industrial closed loop water systems where there's engineers on staff that manage that stuff. Nowadays, the sensors to monitor that are much less expensive and much more reliable. So you're seeing more and more of that type of automatic equipment in wastewater facilities, and it's starting to come down in price enough that you'll start to see it in stone countertop fabrication shops in the next few years.
Good morning, Joe.
Hi,
Good
Omar.
morning, Sarah. I guess I'm not the only EPCO system owner that's not happy with the final product. So I fully understand. I'm wondering maybe if we can hear just how many people have similar challenges. I'd like to hear from you, Joe. Is the level of involvement and time for the 250-gallon system that we were talking about, and the level of automation? How much should I'm just looking for something that I want to put, set it and forget it, like
Right, right,
the oven.
right.
So can you talk a little bit about that and just kind
Sure.
of
Yeah, that's a great topic. So there's two primarily technologies on the market right now. There's the filter press, which many of you are familiar with, where the water goes in. It's a mechanical element it's cloth, stops the solid. Water goes through the other side. You get clean water. They work very, very well at cleaning water. We manufacture filter presses, automatic filter presses. We don't sell very many in the countertop fabrication industry because it's a mechanical filter. It has a cleaning cycle, and that cleaning cycle usually takes a couple hours for most people. And that cleaning cycle is hard to predict. And so when that happens, it can cause the shop to shut down. In addition to that, on a manual filter press, it's very difficult to clean. You have to have some knowledge and expertise, but they do make very, very clean water. Then the other technology that's widely sold and serviced in the industry is settling using a chemistry to accelerate the settling so that the water cleans up faster. Everyone almost in the industry today is using liquids to do that. Liquids are the lowest price, and they're the easiest to dispense because you can use a very inexpensive liquid chemical pump. And the challenge with liquids are if they're not mixed really, really well into the water, into the slurry, and the slurry levels aren't quite high enough, the solids in the water, which is a common issue in fabrication, that the solids aren't, the more solids you have, the cleaner you can get the water with liquid chemistries. So that's always a challenge. The first thing we tell people who have a liquid settling system is make sure the water that is being pumped into the tower is as dirty as possible. It sounds counterintuitive, but the chemistry works best. The dirtier the water, the cleaner we can get it. So if you had a settling pit or your trenches, if a bunch of mud is settling in the trenches before the pit, that's going to directly impact your water quality. It'll make it actually worse. Even though the pit water is cleaner, the final product will be worse than if you got all that mud in those trenches to flow into that pit. The newest development right now in the industry is dry additives, and those dry additives. Back to the liquid first. One of the other issues with our liquid is we have to dial it in, and we have to get it dialed in, because if we feed too much, the liquid starts to counteract itself. It'll fight itself, like two magnets that are reversed. So with liquid, there's a little bit of management of that water quality, and we get mixed results. We'll have a shop using a liquid very effectively. You go to a next door shop, same mix of products, same setup, same water systems, and their water quality doesn't look as good, and they struggle with water quality. And some of that is the sophistication of the maintenance guy. So the dry chemistries that are coming out on the market just now, they've been used for probably a year and a half, but they're just starting to really get a foothold. They don't have that limitation. If you overfeed the dry chemistry, it just cleans the water better, and it becomes more expensive to operate. But you don't have the same struggle you have with the liquid, where if you overfeed, your water quality goes to hell. So managing the water quality piece of it is much, much easier with the dry chemistry than it is with the liquid chemistry. However, it is a little more expensive to operate, and you have to have a good dosing system, to make sure it's going into the slurry when and if needed. So a good designed water system now is something that should be touched 3 to 5 minutes a day, and maybe it has an emergency every 3 to 8 months. And that emergency is, you're low on water, you need to add water, or a sensor needs calibrating. But the pump seals should not be breaking down every 4 to 8 months. They should be breaking down, every year and a half. And a nice designed water system will warn you and tell you when that seal starts to fail, instead of waiting for you to hear the pump bearings going out or the motor failing. So that the technology is all there nowadays to, provide that information instead of waiting for your employee to see or notice it. And it's a snowball effect, because a pump seal on any water system, on any pump, is a consumable item. But you don't know when it's going to fail. And if it's not, if it's something that doesn't require attention all the time, your employee's not watching it. And then when it becomes an issue, usually they haven't noticed it. And pretty soon the water is penetrated the motor, and the motor is shot. And now you're looking at overnighting a product that costs $4,000 or $5,000. And so where if you would have, been able to replace a seal that was maybe $250 proactively before the water got into the motor, it's not a very big deal. So those are the key points when you're looking at new water systems.
I'm wondering, Joe, is there any system out there that could be like a hybrid where you have a liquid and because it kind of makes sense that you
Yes.
would set the liquid at a low dose and then you would compensate with the other one?
Um, yes and no. So yes, you're correct. You can do that. The, the probably the biggest issue we see with that is there's so little that that the efficiency we can get if the dry is if you're looking at doing that, the efficiency we can get with the dry chemistry is such that there would be very little benefit to feeding a liquid and a dry. It seems, it's not a linear relationship, um, but that that is something you could do. Uh, I wouldn't recommend it because it brings another level of sophistication to managing the system. And we have done that on a few sites. We've tried that. And we weren't able to gain very much efficiency, and it required a lot more hand holding, just the way they interact. But
Is there any trick? I think all of us own some kind of a filtration system, and we're all not happy with it. I guess what is the trick for making sure that that water system is working properly, or is it training? Is it equipment? What is it that we can do?
right, right. Yeah, I think, looking at some of these things we brought up, like what are the symptoms? Did they occur slowly over time, or did they kind of happen really quickly? And my gut feel is if they happen really quickly, very likely the system needs adjustments because something went to heck, and isn't running right. And if it's happened slow over time, likely it's just from growth, and that growth has outpaced that system potentially. I would recommend reaching out, and I'm sure some of you have done this successfully at times and unsuccessfully at times, but reaching out to the manufacturer to start. And then, if you can't get it dialed in with phone support and or an on-site person, that's probably the time to look at bringing in other vendors or looking at other options, new equipment, etc. Um, I will say we we have a standalone product, and there's probably a few others now that can be added to existing water systems to help greatly improve their performance. And that would just be a case by case discussion with someone like us or another manufacturers. What can be done to our existing water system? Maybe there's an add-on or something that we can be done to get better results and improve the water quality, improve the uptime. And there's pros and cons to that. The capital investment of a brand new water system in a big shop, can be well over $100,000. And you've already got sunk money into equipment. Is there a way that you can use that existing equipment with a Band-Aid that maybe is a $20,000 add-on and get some more years out of it? And then the challenge you always got to think of there is on a hybrid system like that, how much more hand holding and management is going to be required by you and the employees. Sometimes, in some cases, it isn't very much. In other cases, it can be a fair amount, enough that it becomes too painful, where the depreciated capital cost of the new equipment is worth it because you're not going to have as much management. Other questions?
You're gonna be at Tice, right? So we can stop by
Yes.
and see you.
Yep. Yep. And we are showing some equipment that's not even released to the market yet. We'll be showing some technology there. So if anybody wants a tour of kind of what the future's bringing, come on over and we'll just walk you through that.
Well, that's awesome.
Some of those.
Perfect. Thank you, Joe.
Yeah, thank you,
thanks,
Joe.
Omar.
Any other questions, anyone?
One of the things
so.
that I was just going to mention is, years ago, my father was a plumber, and he was in the business of selling water softeners. And if the softeners have to be sized to for the amount of water that you're going to be running through there. Otherwise, if it's sized too small, you're just going to be that thing will be constantly running, and your costs of salt or whatever you're using to as the ion exchange into that, you're just going to be burning through stuff like crazy. And
That's
so
correct. Yeah.
the design, the engineering and stuff has to be right the first time.
Mm-hmm.
And it's got to be designed in a way, if you're going to plan on growing, you've got to plan way ahead, not just come in and slap it in and, well, you just bought a water system, but you find out that it's actually not adequate for what you're doing.
Right. Right. Yeah. And I think that gets back to that add-on or upgradability or add-on potential. If you're looking at a water system, is there a clear answer as to, hey, I'm producing 600 feet a day. I might be producing 2,000 feet a day in 3 years. What does that process look like with a piece of equipment? Is there an add-on, or is there an upgradability, or that's a great question to ask.
Very good.
Yeah.
Joe, can you hear me?
Yes. Yes.
This is Joseph Frame, Del Bartolo's associate. I don't have a camera on my computer, but I'm the maintenance manager out here to Countertop Source in Hurricane, Utah. And Del's
sure.
He's our resident plumber assistant guy that I have and to help me quite a bit with. Anyway, so we average about 650 feet, linear feet out of the shop a day. We have a 10,000 gallon EBCO system. We're running anticoagulants. And the reason why we're running chlorine is to kill the algae. And also we're running a peroxide as well. But
Okay.
I've never used bromine. I'm not quite sure why. The person who was running up before us never did that. And I'm wondering, but it sounds like it's not quite as aggressive. And the biocide is really interesting. And
Yes. Yeah.
to help us kind of knock down that really stinky smell. Because
Right.
he'll go and put in, a couple of gallons of chlorine in the trenches to kill all the algae and stuff. And it's quite smelly for the guys in the shop, and they kind of whine about it a bit. But I think the biocide was kind of interesting. I just wondered what website, or maybe you could send us a little bit of information on that.
Sure. Yeah, there's non-oxidative biocides. And there are chemical companies. Utah's a funny state because there's a lot of major manufacturers of very large wastewater equipment in Utah for whatever reason. But there are chemical companies that support biocides in pretty much every state. Some of them are multi-state companies that where you can just go pick it up. You can buy a 5-gallon bucket, pull up at their shop and pick it up, or they can ship it to you. And like I said, I think you can even buy biocides on Amazon. They're typically around a good value in a biocide's around $300 for a 5-gallon pail. And that's some of them are better at funguses, and some of them are better at algae, and some of if your shop is indoors, most of the biocides are going to work really well. If you're down south outdoors, you might want a particular biocide, and that's something, like I said, it just can be hand dosed. You know, they like to normally, if you went direct with a manufacturer, they would tell you, okay, how much water is in your full system, and then they would tell you how many ounces to hand dose every once a week. Normally, I've been instructing, I've talked to 3 or 4 manufacturers of biocides over the years, and I've been instructing shops to, when they buy it, to dose it on a Friday. If the last day of the week for you. If it's Saturday, do it then. If it's Friday, do it then. If it alternates between Fridays and Saturdays, I'd tell the guys to do it Friday, and I dose it a few hours before the end of the day, and that provides a kill. And then the weekend, it's not growing. You don't have where if you did it on Monday, I think you'd be chasing your tail a little more. And that's kind of what we've seen and experienced from a handful of shops that we talk to about how they use biocides. The reason we don't currently do it ourselves is because it has to be registered in every state, and that process isn't quite as easy. And transporting it, that's part of the registration process. Because it's if you had a 5-gallon pail of biocide, spill in someone's backyard in their swimming pool, it wouldn't be a good deal. So the government regulates it a little heavier, and it makes it difficult for anybody to distribute it across the entire North America, marketplace.
About the only biocide that we're using right now is this
peroxide.
Well, yes, we do use liquid peroxide, but we also do an algicide to bring the pH down to get that acidity up.
Sure.
What is that green stuff we're using, Dal? Do you remember what that's called?
Which one?
The one in the green bottle that we usually add.
Oh, that's acid.
Oh,
yeah.
Okay.
It's kind of an algicide, they call it. Yeah, right.
But so it's lowering your pH a little naturally as well.
Right.
Yep.
Yeah.
Yep.
It's
So, Joe, my question for you is, and we've kind of kicked it around a bit, is in your reuse water, what is the ideal pH for the reuse water?
You're right. Yeah. Great
is
question.
It 8.5? Is it 7? What is it?
Yeah. So you have multiple things that have different pHs they like. So there is no one right answer. When we look at it as a blended answer, like where is a good range to be in, we like to be between 7.3 and 7.7. So like 7.5 is a target. And the higher the pH, the less comfortable it is for your employees, like your hand polishers. Right. It also scales more. So higher pH water will deposit more scale. It'll precipitate out scale more. You're going to have more chalky debris. But the lower pH is aggressive on your equipment. So if any time you get below, and each type of, so mild steel loves 8 pH water. Aluminum, likes a different pH water. Stainless steel is more robust around across a wide range. But 7.5 is a nice target I would be comfortable with. I would say in North America today, probably only 1 out of 5 shops are below 8. Routinely, I would say 4 out of 5 are slightly above 8 or higher. Most of most shops, if they don't do anything to their water, are running around 8.2 to 8.3 is really common. Um, just due to the nature of the materials that are being fabricated and how they interact with the water chemistry. Um,
Okay, I think you've answered my question. Like the compressor just probably came on the background, so I'm out.
oh, okay.
So what we use is we use muriatic acid once in a while to drop the
Sure.
pH if we need it to drop fast. But we've used hydrogen peroxide. It's something like I think it's the 14.5% or whatever it is. And that's to just drip in to bring it down slowly. But then we would add the sodium hypochlorite or the bleach to the to the trenches to kill out the algae. But I'm for anything that I can get away with not having to handle that stuff because it is
Right.
corrosive.
Right.
And
Right.
if I can add bromine to it once a week rather than going and getting pumping out 2 gallons of bleach to add to the trenches, because
Right.
both of those are, I mean, just the handling of it bothers me just because of having that interaction. And if somebody doesn't know what they're doing, you're
Right.
you're just that's just one of those risks that
Right.
I I would
Yeah.
rather do it myself than try to tell somebody else how to do it.
Yeah.
And I don't
Yeah.
even like to do it,
Right.
but I
Yeah.
I do it every single day.
I agree. I think so. What I would suggest, simple thing is to buy $120. I don't know how much it is in your market, but it's probably around $100. Pool chlorinator ball and buy some bromine pucks and throw. Probably depending on there's two sizes of bromine pucks. There's a real small one that's common. It's the size of a quarter, but it's about 3/4 of an inch tall. If you were using those, I'd throw like 8 in every month, just the first day of the month or whatever, into that ball and throw that ball on a little rope into your either
Just set it,
your
just dangle it down into the pit or whatever.
yep, you could put it in the pit or in your clean tank, wherever it's easiest. And then
So,
and then that'll slowly dissolve over the course of that month. And then
oh, okay. Well,
the, a cool
that actually gives me an idea, because what we've done is we've got our little peroxide tank. We actually set it on top of a plastic 55-gallon drum that we can actually monitor the water that goes into that. And then if the pH comes up, it drips into that barrel and then trickles down into the pit. Whereas before, the monitoring device for the peroxide, the pH deal was actually clear down inside the pit, and we couldn't maintaining it was an absolute nightmare.
sure, sure,
So that gives me an idea. If we was to take the bromine ball and drop it into that barrel,
sure.
then that would be a simple fix. But a 55-gallon drum of bleach is almost $900.
Yeah, right. Yeah.
And when you're going through one of those every 2 months,
Oh, yeah, yeah. So, and
you
the
know,
reason you're doing that is because you're smelling that odor.
yeah. And
Yeah. So I would,
that's just to
yeah,
kill the odor so it doesn't build,
yeah,
to kill that so that algae doesn't grow in there.
yeah. I would try to pick a weekend, do a deep cleaning, have a biocide, start using a biocide. Like I said, it'd probably cost you $300-400 a year for that biocide. And
Wow.
then I would use a bromine pool chlorinator ball, just bromine tablets every month. And if you did those two things, you'd probably, cut your bill below half and eliminate, I think, a lot of that handling of that drum of chlorine and stuff, that concern.
Yeah, it's
Yeah.
and I'll tell you, our experience is whenever these barrels show up, they put them on the worst pallet that they could have ever picked.
Uh,
It's like they're trying to get rid of their junky pallets,
yeah.
and then it becomes a handling nightmare when it comes to trying
Right.
to move the barrels around.
Yeah. Yeah. And I'm thinking, you should see, you've probably seen signs of corrosion. Um, but with the biocide and the bromine, your metal would be a lot happier, the
Oh
equipment in
yeah.
the shop
I
too.
mean,
So
Yeah.
just the fumes, the vapor, the fumes that come off of that bleach. Oh my goodness. That is, it's just
yeah.
crazy. Was it what that does to the
It
metal?
does. Yeah.
Right.
I'm for anything that's safer and way more cost effective.
Yeah. Yeah.
Agreed. Agreed. Unless anyone else has questions, I want to thank you, Joe. This was amazing. Very informative.
Yeah. No problem.
Thank you,
All right.
everyone.